So, Shaju, why don't you give us a little bit perspective from Tata and yourself in terms of software-defined vehicles and how you see the world, and then Dan, I'll ask you the same question in a second.
Sure, thanks, Steve. So, as we all know, we have seen a transformation going on in the mobility segment. We know or we knew vehicles as a mechanical device. Then we saw a lot of electronics go into it as the next stage. And with electronics came in a lot of software. And now what we are seeing is that software is going to define how the car is going to be behaving over a period of its lifetime, like including software and including feature additions that will happen over a period of probably 7 years to 11 years that we are looking at as a lifetime for the vehicle. So the software is going to play a very critical role, and companies like us, Tata Elxsi, for example, have been working on this for many years on the software side. On the domain side, we have built a lot of assets which will then enable this whole transformation from being a distributed system to a domain-based, to a zonal and a central computing, which will then enable the software-defined vehicle concept.
Okay. Dan?
Yeah, so one of the things that we see at Green Hills is the automotive industry evolving from the hardware-centric approach of adding features and functionality from hardware to moving more toward a software-centric area. And in the 40 years we've been in business, we've actually seen this transformation take place in a number of other industries. It's already done and taken place in military and aerospace, in the aspects of things like software-defined radio, where you've gone from having multiple radios at different levels of criticality or information and bringing it all into one radio. We've seen this in rail, where we've built Senelec systems where the policies of different countries, instead of having them in each individual boxes, they're done in a central control system and done and separated through software. So we're ready and have a lot of experience on helping our customers build systems that are software-centric, software-focused, while also maintaining the requirements for safety and security and separation, mixed criticality aspects. So those are the areas that Green Hills focuses on in the software-defined vehicle. And as was talked about in a number of the discussions that I've had yesterday and this morning, one of the big things for software-defined vehicle, it's going to take a significant amount of collaboration by many companies that are experts in who they are and what they do and what they bring, and some of the new things that they're bringing and new development. So it's an exciting time, and there's players that it's going to be revolutionary. It's definitely not an evolution in the car architecture, to say the least.
So I mean, Shaju, you mentioned sort of the distributed compute and the moving to sort of domains, and you were talking about different areas of expertise. If we step back for a second, the software-defined vehicle is a very sort of like generic term in some respects. From your perspectives, what is it just the chipset and the architecture, or is it something broader than that? Shaju?
Yeah. So, like I mentioned, it's about giving a new level of experience for its users. Yeah, like your smartphone, for example. Whenever a new feature comes out, you don't go and change the hardware. Instead, through a software update, you're able to get the new features in. That's the level of experience that the users would expect. From an OEM or perspective or a manufacturer perspective, he would like to monetize whatever he is investing into this over a period of its lifetime. So these two are the key aspects when we move towards a software-defined vehicle.
But is it just this chipset, or is there aspects of safety or other solutions like personalization or connected services? I mean, how do you address all of those different things?
Absolutely. All of that has to be taken care of. Safety is paramount. Security is very important. Of course, personalization. So there is a very narrow line between must-have and useful to have kind of features. Yeah, that's narrowing down. So it's kind of coming closer. I would say all of it have to be taken care of, and it has to be future-proofed for many more years, because we know the kind of evolution that is happening. So that has to be built into the overall plan when we move towards a software-defined vehicle.
So Dan, when you're having conversations with OEMs and tier ones, I mean, how do you have that broad conversation in terms of, do you understand what a software-defined vehicle is, or how does the conversation start?
Boy, software-defined vehicle can mean many things to many people. I mean, if you look at what makes up a software-defined vehicle, first of all, it's the separation of the software functions and capabilities, the development processes, everything about the software separated from the hardware being the ECU modules and what capabilities are available today. But if you look at from a functionality perspective of software-defined vehicles, the fact that the tenets that make up software-defined vehicle are it must have system safety design, it must have security policies and practices, it must have autonomy, it must have connectivity, it must have personalization, it has to have all those. And with all those, in order to realize the vision of a software-defined vehicle, not one has a priority over the other. They all have to be there, and they all have to be incorporated from implementations and best practices from people that either have those capabilities or they're developed in-house. And they're all the same priority. They all have to be done. You can't have autonomy without safety. You can't have security. You can't have connected services and OTA without security. And you can't have the vision of realizing revenue over the lifetime of the vehicle without all of them in place. So it's it's coming to a realization that understanding what a software-defined vehicle really is, and it's not an ECU module, it's not which CPU you're using, and it's not certain aspects of it. Those are the tactical sides. Strategically, it's a game changer. Everything's changed.
So these are complex systems that you've just been talking about, and already there are anywhere between 100 million lines of code and 200 million lines of code. How are the OEMs approaching this in terms of trying to mitigate that complexity, either in terms of the design element or in terms of the code and the sort of the approach to their software? I mean, how do you address that with them?
Right. Well, so that's a good question about what's happening. What I talked about, the system is going to become even more complex in dealing with multi-core processors, more powerful hardware, more lines of code, and what has to happen is the current practices and techniques on software development, software debugging, continuous integration, validation, test, they've got to change. It can't be it can't get incrementally better. It has to change. From our perspective as an embedded software company, we have different business units, and one of our business units is development tools. And we have very advanced development tools that are optimized to work in multi-core, multi-heterogeneous, multi-OS environments. And when we work with customers and we see some of the problems they're facing, even in today's architectures, and we still see them using the most advanced debug feature they use is printf. And the impact that has in the overall system behavior, the ability to actually locate and to find a bug and fix it, these are the types of things that we look at that absolutely have to change, and you have to start enabling the developers to be more productive and be able to understand and use these systems much better. Those are some of the, from our perspective, I mean, things have to change. It can't just be incremental. Okay, well let's use a better printf. Let's use something different. So it's really challenging.
I mean, you mentioned a couple of things: ecosystem, developers. I mean, partnerships, different mindsets and approaches to software development. Shaju, you've partnered with Green Hills. What was the motivation for that partnership? And are there any lessons that can be learned by the industry in terms of that partnership?
Sure. Before I answer that, please, Steve, if you may allow, I would like to take the previous question and add a few points. Yeah. the complexity is only going to go up. The number of lines of code is only going to go up. The earlier we put processes in place which can cater to these complexities, better position we are in. From a Tata Elxsi perspective, our stance is that we are not going to go and build everything on our own. We have our strengths. We have the domain strengths. We have assets that we have created. We have strong validation and integration skills and capabilities that we have in-house. We were going to harp on that and build on partnership with the likes of Green Hills, which brings in strong platform capabilities of software. So that's the approach that Tata Elxsi is going to take. And I think that's the way forward for the entire industry. Rather than try and go and build everything yourselves, partner with people who have core strengths in each of these areas and develop systems which they have core capabilities and strengths in.
Good. And does that mean that there's got to be some form of standardization in terms of an approach? I mean,
yes, there has to be a standardized approach. Otherwise, everybody is going after the same thing and trying to invest money into certain things which can be done better if we collaborate and commonalize some of these things.
so if we start to talk about the evolution of software-defined vehicles, I mean, what are the challenges that are here now, but that are likely to emerge over the next 5 years?
From a challenge perspective, I would start with the hardware platform itself. You need to have a compute platform which is capable of delivering features for the next 5 years, 7 years. Once a car, it goes in, it stays there in the car for 5 years, 7 years, number one. Number two, you need to have a very stable and robust software platform which is capable of catering to all the aspects, whether it is security, safety, you name it. All those have to be catered into that platform. Then comes the domain aspects. Which are the features that you want to build up front? Which are the features that you want to make it optional? I'm talking from a manufacturer perspective. And how do we monetize these? How do we entice people to get onto these features and start using them so that it generates revenue?
Dan?
Yeah, so the evolution, well, I look at the software-defined vehicle and this whole, it's more of a revolution than an evolution, to be honest. It's not a trip, it's a journey. I mean, it's going to take a long time to get the foundational pieces that you need to do in place without compromise. And you want to do it in a way, and it's important that you do it upfront in the right way so that you can evolve and have a scalable, portable architecture and processes and practices that can bring in and take advantage of new capabilities and techniques that are being developed now or haven't even been thought of yet. So you've got to put yourself in a position to, first of all, implement what you can based on what's available today, thinking about how you're putting all the different tenets in place, and then putting yourself in a position to, once you've done an evolutionary change within your organization on how you're structuring software-defined vehicle development, then you can start evolving with new architectures as new SoCs become available, new algorithms, things that can do better and work differently with some of the sensors and technologies that are already in the vehicle. So it's a big challenge.
So if I pick up on complexity, software-defined vehicle makes it sound as if it's on the vehicle. But, Shaju, you brought up platform and cloud capability. When the OEMs are thinking about their cars going forward, that must mean that they've got to be thinking not only about the car today, but the car in potentially 10 years' time and what that capability is. I mean, is that a challenge? I mean, does that increase the time to market, or what's the evolution process in trying to deliver that?
I think, as Dan said, we have to take one step at a time. We need to look at the problems that we want to solve now and probably a period that we define and move forward. And as you said, I mean, it will be a combination of systems in the car and the cloud. Of course, with the connectivity, a lot of things can get pushed onto the cloud, but there are still safety critical systems which will still need to reside within the vehicle and not on the cloud. So, short answer, take one step at a time. That's the approach that most of the OEMs are taking. They're looking into the future for sure, but they're not going to decide what will come 20 years down the line.
Dan?
Yeah, well, I think about, one of the big changes is when you talk about hardware-centric versus software-centric, to date, all the ECUs in the car have been purpose-built for a certain function and capability. And when you wanted to add new features and capabilities, the past practice and current practice is, okay, well, we need to design a new ECU to add that. We need to update and redesign this new other ECU that we already have, and it's very hardware-centric, and it doesn't scale very well. And that's how we're getting to the point where we have all these ECUs. So moving to a software-centric approach, your design goals are how you can look at things from a software perspective, independent of the hardware, and also give yourself the ability to move those easily to different hardware platforms versus being so tied and coupled to it. So,
and taking that in, I mean, you and I had a conversation outside. You have to start that process with security in mind, right? I mean, it can't be a bolt-on or an add-on. I mean, the cybersecurity as opposed to the safety. I mean, has to be in there from day one, right?
Yeah, but both safety and security are important foundational aspects of the software-defined vehicle at the very underlying layer. They're the pieces that need to be in place to be able to properly host, execute, separate, and guarantee execution of the pieces that are of the OEM OS. The OEM OS and all the services and cool things that are being developed and are going to be developed in the future. The safety and security isn't very sexy. It's hard to do, but you have to do it right from the very beginning, because you can't really effectively OTA in security or safety. If it's not foundationally there, you can't just go and patch in better or more robust safety and security foundationally. If your system's inherently insecure when you start, then when you patch or add things in, it's still inherently insecure, and it will always be that way. So we've done some of the most advanced safety and security systems for multiple industries, systems that have achieved the highest levels of safety and security, systems that have been mathematically proven to provide separation, where each line of source code has been evaluated and looked at. I mean, we understand it down to that level, and with the effect of a processor cache has when it's multi-core and all these things. So those are the things that, not sexy, but they have to be focused on, and they have to be foundational so that the sexy things can be updated, run successfully, not compromised, and affect the safety or security of the system or the data that's in the software-defined vehicle.
Okay. Are there any questions on the swap card? No? And any questions from the audience? Anybody have a burning question that... Okay. So if we come back to the sort of fundamental building blocks of the SDV, I mean, what are those key building blocks in order to be able to sort of see the thing evolve? So, Shaju?
Yeah. As I said, hardware, the compute platform, the software platform, the domain-specific apps, and the application, the domain-specific software and the applications that sit on top of it. And to make it more complex, you have a whole lot of validation that you will need to do. So you need to have a very robust validation. And of course, the development side, you need to have the CI/CD framework in place, which will keep the pipeline robust and make sure that you're able to push in software, validate it, and push it out as there is a request for the same.
Any other building blocks, Dan?
Yeah, I think of three things that are important. Again, from our view of Green Hill Software, what we do and what we look at and problems we help our customers solve. The first one is having an architecture and an organization that is organized to be software-centric, moving away from hardware-centric. That must get done, from the engineering organization to management to purchasing. I mean, every organization gets affected. So you have to have that in place. Then again, from our perspective, putting in the best practices for code design, code debug, the continuous integration, validation, test, and delivery and update to the vehicle as they're being deployed. And then the third thing is that you absolutely have to make sure that you're not compromising on the key foundational components when it comes to designing a system with safety and security in mind. So those are the three things that we look at, we focus, and we're working on with customers today.
In the last 30 seconds that we've got, it strikes me that one of the most important aspects is how do all of those components connect? Is there a requirement for a different or an enhanced backbone for communicating between the modules and the domains?
Of course, the number of modules will come down when we move towards this architecture, but whatever modules we have, they definitely need to collaborate and communicate very seamlessly.
Okay.
Yeah, well, there's definitely the need for the higher speed, going to next generation backbones. The numbers I've heard are 1 to 2 terabytes per day per car that are going to be transported up to the cloud, but that data is coming from the vehicle, so there's a lot of things going on inside the car.
Super. Shaju, Dan, thank you very much for your time and your insight, and look forward to talking to you more over the next couple of days.
Thank you, Steve, and thank you, everybody.
Thank you.
Good round of applause.
Good job.